minus mg by RT times dH. Well, that's a differential equation you have got integrated now between the limits. So we know that when we integrate it at zero height, the pressure is P naught, and at height h is the pressure I want, P. So get this result and solve it. So what's the pressure you get? So P equals P naught e power minus mgh by RT. So I'm writing it here on top. The result that you get by integrating this, P equals P naught e power minus mgh by RT. This is known as the barometric formula. Yeah. So next question, which is in a similar concept. Let's see. You have a test tube or a long tube, you could say, which you are rotating in a vertical, along the vertical axis. It's horizontally rotated. This is the question. This is the axis, and this is the tube which is being whirled like that. Now this side of the tube is open, so the pressure here is P naught. It is rotated with an angular speed omega. So I want to find out, assume temperature to be constant here. You can take molecular mass of the gas as m and radius as r. I want to know what is the pressure as a function of radius. Pressure as a function of radius r is how much? You are whirling it in a vertical circle as shown. So have you you chosen an element there? If I take a certain element of thickness dr, how do I draw the free body diagram? I am drawing it on the side here. This is the element dr. So what forces are acting on it? What is its acceleration?
Acceleration omega square r towards the center.
So it will be omega square r towards the center, the centripetal acceleration. And forces acting, we can say, well, PA and P plus dP times A. We don't bother about the weight. Weight will act vertically downwards, so that won't influence this result. So, having written this free body diagram for radial forces, we can write net force inwards P plus dP times A minus PA is equal to mass into acceleration. What is the mass of this? Rho A dr. Density into volume. So can you integrate this and get your result? So A cancel throughout. So we get dP cancel. So dP equals omega square, rho omega square. But rho will have to write down. What is rho? Rho is a variable. As in the previous case, rho happens to be Pm by RT. So Pm by RT omega square r dr. So we integrate this suitably and get the result. So dP by P is equal to m omega square RT times r dr. We integrate and get the results as in the previous case. So if you start with 0, the pressure is P naught. At r, the pressure is P, and that's what you want to know. So get your result. So final result, P equals P naught e power, we can say. We can also say exponential m omega square r square by 2RT. We say like that. The pressure as a function of radius. Yeah, is it fine? We move on to the next question. In a certain process, the pressure of the gas is given by P equals P naught minus alpha V square, where V is the molar volume. In a certain process, the pressure of the gas is given by P naught plus alpha V square. P naught and alpha are positive constants. So get me the maximum temperature in this process. How do we start this?
We can replace P by RT by V.
Yeah, you create a temperature function and solve it like a maximum minima question. Do that. Now when you say molar volume, then M equals 1. Okay, this is the V, the volume of 1 mole. So temperature becomes P naught minus alpha V square times V by R. Or shall I say temperature is P naught by R times V minus alpha V cube by R. So how do we go about for maxima? We differentiate that. So when you differentiate it and put it equal to 0, what do we get? Yeah, so you're doing it dt by dv equals 0. What's the volume that you get? And how do you know it is maxima? Yeah, so how do you establish it's a maxima?
So d square t by t square.
Yeah, exactly. So if you double differentiate, you will notice that it is, if you double differentiate and substitute that value, you will notice that it is negative. So hence it will get a maxima. I can give you the final answer, so give me the answer. T max, I'll put down the answer. T max equals how much? It's not so complicated. There is one under root sign and you don't have to evaluate anything. No, there is only one factor.
Alpha by RCC.
2 P naught by 3 R P naught by 3 R.
Under root.
Yeah, under root P naught by 3.
Do you get that? Maybe you can give me, whoever got this answer, just give me what's the volume you got?
Sir, under root of
P naught by
P
3
naught by
alpha.
3 alpha.
Under root of P naught by 3 alpha, is that it? Okay, are you getting this? So we put on a temperature function there and solve it like a maximum minima question in mathematics, and therefore we get the maximum temperature. To establish it as maximum, you have to differentiate and equate, differentiate and prove less than 0. Yeah, can we move on now? Yeah.
Can you explain once again?
Okay. See, this is a certain process, and the question, what was the question? Question is, what is the maximum temperature during this process? So first of all, we try to find out what is temperature. Temperature from ideal gas equation. PV equals nRT, T equals PV by nR. Now this volume given is molar volume. Molar means volume of 1 mole. So I put N equal to 1. So the expression I get is T equals PV by R. So P given to you as P naught minus alpha V square. So we put P naught minus alpha V square into V by R. Okay, so far we multiply this, we get this equation. This is the temperature versus volume function. Temperature versus volume function, temperature, we don't know how it is going to behave. So there is a certain maxima, that is the idea, because you are being asking for maximum temperature. So how do we solve for maxima? You know, we differentiate. Are there maxima, minima in mathematics or not?
No, sir. On the way in physics.
Huh?
In physics we have done.
Okay, maybe that's why you are a little hesitant. Are you aware that maxima means dt by, I just explained it to you in a short while. See, I'm just taking some space here. I'm quickly reminding you of, see, any function, if it is like that, let us say it's the temperature, here temperature volume function. If the function is like this, some arbitrary shape, you can see that this is the minima, this is the maxima, this is the minima, this is the maxima. At the peaks or the valleys, the slope is 0. That's what you can distinguish with your eyes as peaks or valleys, maxima or minima. Slope is 0 there. So we put dt by dv as 0. So we put dt by dv as 0 here. Put dt by dv equal to 0. Alright. I'm just referring to it in maxima minima. You will do it in detail. But have you done this or not? In physics, in the very beginning, you might have done it. Yeah. Yes. No. What? Yeah. Are you aware of differentiation or not? Can you differentiate this function?
Yes, sir.
Okay. Let me do it step by step and let us see. See, what we will do is, for those who have not done that, for those who have not done maxima minima, I'm just giving short notes. Note this down, and we can proceed from there. For maxima or minima, dy by dx equals 0. For maxima, d square y by dx square is less than 0. For minima, d square y by dx square is greater than 0. Just take this package, this is what you have to employ. Okay? Exactly why it is so. This part I have already explained, why dy by dx is 0. If you take this as a y function, as x function, when y versus x, some strange shape, you can understand that A, B, C, D. You understand that A and C are minima, B and D are called maxima. Yeah, is that fine? This part. Now, at maxima or minima, the slope is 0. Are you aware that slope equals dy by dx? Yeah? So, here you can see that A and C are minima, B and D are maxima. But whether it's minima or maxima, slope will be 0 as shown by those red lines. So hence we have put dy by dx equal to 0. Now whichever point satisfy this can either be minima or maxima. Then how do we know if it's minima or maxima? For that you put this criteria, this test. So at maxima double differential is less than 0. At minima double differential is greater than 0. We'll employ the same idea here. Let's see. If I differentiate this, what do we get? If you differentiate this, you will get dt by dv. dt by dv is p naught by r. Differential of v is 1. Differential of v cube is 3v square. Like that. Put this equal to 0. When you put this equal to 0, you get v equals p naught by 3 alpha under root. You get v equals p naught by 3 alpha under root. Now, again substitute this. If you substitute this, what do you get? You can double differentiate. What is d square t by dv square? That means you differentiate this. If you differentiate this, you get minus 6 alpha v by r. Now, v you can substitute this, but no need to put, because anyway negative sign is there. This is less than 0. This means this is maxima. So corresponding to this volume, you get a maxima. Okay. Now take this volume and substitute in this again. If you substitute again, you should be getting this answer. Is that okay? Substitute here. Get this answer. Yeah, are you okay with this question now? Yeah, those of you who did not understand maxima minima earlier, are you okay with this question now? Yeah? Alright, let's move on. Yeah, take up the next question. A vessel of volume 30 liters contains gas at 0 degree centigrade. A certain mass of the gas is let out such that pressure changes by 0.78 atmosphere. We assume that temperature is constant during this process. Density of the gas at STP is 1.3 gram per liter. Density of gas at STP is 1.3 gram per liter. What is the mass of the gas leaked out? Did you get the question? A vessel of 30 liter volume, 0 degree centigrade, contains gas. A certain portion of the gas is leaked out, whereby the pressure in the vessel comes down by 0.78 atmosphere. Temperature you will assume as constant. It is also given that density of the gas at STP is 1.3 gram per liter. How much mass of the gas was leaked out?
So do we need molar volume?
You can use that idea that 1 mole of gas occupies 22.4 liters at STP. You may, I do not know if it is required. You will check it out.
It's
Yes,
required.
it's required.
But here you are given the densities. Let us see what happens here.
31.2.
I think it's I don't have the 30. It is something like that. Let us see. I don't have the final answer. I have it in general form. I don't have the numerical answer. I think it was 30.4 if I recall correctly. Let's check it out.
So 30.4.
See, the PV equals nRT, mass of the gas by molecular mass. Now if you leak out a certain gas, the mass becomes m minus delta m. So the new pressure is M minus delta P. So if I subtract it, what do I get? I get delta P times V is delta M by capital M RT. Okay. So now delta M is here. Delta M is here. Now this is at 0 degree centigrade. So what is it that we require? The density of the gas at STP.
So we need the molar volume.
You require the
Molar volume.
no, you don't require. You see, rho STP is how much? Rho STP stands for pressure P equals rho by M RT. This is this RT by M. We do not know which gas it is, but we know that RT by M is this is pressure at 0 degree centigrade. So what is your RT by M? RT by M is P naught by rho STP. So we can replace this by the definition P naught by rho STP. You get your delta M from here.
So P naught should be taken as 1.
Yeah, that's 1 atmosphere. P naught is 1 atmosphere. Delta P is also equal to atmosphere. So you can get your answer like that. So delta M equals rho STP delta P into V by P naught. Calculate this. That'll be easy to calculate. Rho is 1.3 into delta P is delta P by P naught is 0.78. Volume is 30. So 1.3 into 0.78 into 30 should be the answer, whatever that is. So many grams.
30.42.
Yeah. So I think you're getting it as 30.4 grams, right?
Yeah.
Well, that's the answer. 30.4 grams is the answer for the gas leaked out. The next question. A vessel of volume V is evacuated using a piston air pump. One piston stroke can capture a volume delta V. How many strokes are required to reduce the pressure in the vessel eta times? Assume the process to be isothermal. See, first of all, understand what is this piston air pump thing. So you have the gas here in that vessel. Now this is just like your, suppose you have a bucket of water and you put your holika pichkari in that and you drag it out and then you throw out the water. So if you repeatedly do it and throw it out, so how many times you will have to put that piston inside to empty the bucket? But in a bucket, it's a case of liquid. This is a case of a gas. The idea is same. So can you find out? See, first of all, we'll think of it like that. First, let us understand the process here. There will be some kind of an inlet from where you put that piston inside. Let me show it here. You put that inlet